All right, crabs. You may have heard that several different types of crustaceans have evolved a similar crab-like body plan from different ancestors, and this process is known as carcinization. Trees are another example of this. Most trees are not closely related to each other. They're different types of plants that have evolved a similar tree-like body plan to best absorb as much sunlight through photosynthesis, and this whole process is known as convergent evolution. Convergent evolution is a well-documented phenomenon, the most common example of this being how sharks, dolphins, and extinct reptiles known as ichthyosaurs all resemble each other and fill a similar niche in the environment despite coming from completely different groups of animals. And this makes sense because they're all fast-moving marine hunters, so that body plan works well for that niche. However, convergent evolution doesn't always make this much sense. Lizards are a common group of reptiles found on all continents except Antarctica. Yada yada, you know what a lizard is if you're watching this video. But what we may not know is that several different types of lizards have independently evolved to lose their legs. These groups are often referred to as legless lizards, being that they are lizards without legs. The most common example of this that you've definitely heard of being snakes, but there are also Amphisbaenians or worm lizards, but there are many other groups, including the snake lizards of Australia and New Guinea, some types of spectacled lizards, several different types of skinks, California's American legless lizards, and many more groups that I don't have time to list here. Now, I know what some of you might be thinking. Lizards without legs? Isn't that just a snake? I mean, all of these look like snakes. But that's the interesting part. They're not snakes, except for the ones that are snakes. But the other ones are not snakes. The basic body plan of a lizard looks something like this: a head, four legs, and a tail. In many ways, they resemble the common ancestor of all amniotes, or animals that lay eggs, hard-shelled eggs that live independently of water. And many groups of lizards differ from this body plan. The mosasaurs of the Cretaceous period are one example of this: giant marine reptiles that swam the seas at the same time as Tyrannosaurus rex stalked the land. There are many other groups of lizards that deviate from the basic body plan. Around the same time that the mosasaurs were evolving, and possibly from the same ancestor, one group of lizards developed a radically different body plan. Their arms and legs became reduced to such an extent that they lost all function and eventually disappeared. These became snakes. It seems odd that an animal would evolve to lose a trait so seemingly beneficial as its legs, which is why it was a surprise to me when I found out that this has actually happened several times independently. While snakes all descend from a common ancestor, likely a close relative of monitor lizards and the mosasaurs, many other groups of lizards have convergently evolved a snake-like body plan wholly unrelated to them. Now, normally when you look at the difference between a snake and a legless lizard, you will learn about how many legless lizards have eyelids and external ears, while snakes do not, and that a lot of legless lizards still have some form of vestigial limbs, while snakes have completely lost all trace of their ancestral limbs. But what I'm interested in with this video is that all these groups descend from a different four-legged common ancestor and convergently evolved to the limbless condition. Now, what do I mean by this? I mean that the common ancestor of all these different groups of lizards had four legs, and then each of them independently lost them over time until we get to today, where we have more than half a dozen different groups of lizards without legs, which is a type of convergent evolution, or an example of convergent evolution. For the purposes of this video, I'll be using a comprehensive 2013 study by Pyron et al. On the phylogeny of squamates, lizards and snakes, with the tuatara of New Zealand being the outgroup. The study is linked in the description. Here's the full tree of the group study, zoomed out to the point where you can't read it. But for reference, the tuatara is up here as an outgroup. Everything down here are snakes. Amphisbaenians are here. Geckos are up here. And skinks are about here. One of the things that makes this so interesting is that there's only one other group of tetrapods, animals with four legs that descend from a common terrestrial semi-aquatic ancestor, where multiple groups have lost their limbs independently, that being amphibians. They're also the only group of tetrapods to have lost their limbs at all, with caecilians and a few other groups of salamanders and multiple extinct forms having lost or greatly reduced their limbs entirely. But amphibians are in a bit of a different situation than lizards. One, it's possible that a limbless body plan is much easier to evolve in amphibians because most amphibians have a tadpole larva stage where they are limbless, and through neoteny, the retaining of juvenile features into adulthood, another very common evolution phenomenon, they could become limbless. Sirens, for example, are a family of salamanders that are basically just giant tadpoles with front limbs, although in some species they have also been reduced. Lizards, by contrast, had to evolve to lose all four fully functioning legs. The other issue is that most groups of limbless or reduced limbs amphibians are aquatic, meaning they show more convergent evolution with eels than snakes, except for caecilians, who really deserve their own video. I don't have time to touch on them here, but most legless lizards, on the other hand, are terrestrial. Although there are aquatic snakes, all species alive today are generally believed to descend from a common ancestor that is terrestrial and did not have legs. That still leaves us with the question of why. Why have so many different groups of lizards, and largely only lizards, lost their legs so many times? Maybe if we look at several of the different groups of legless lizards, and see what they have in common, we might come across an answer. Snakes are likely the oldest and most widespread and the most well-known group in this video. Since you likely already know what a snake is, we are going to move on to less well-known groups. Some of the most well-known groups of legless lizards belong to the family Aguidae, a diverse family of lizards native to the northern hemisphere. Legless species occur in three genera: Anguis, which is the slow worms, Ophisaurus, or glass lizards, and the closely related Pseudopus containing one species, the Sheltopusik. Yeah, I'm not the best at pronunciation, but we'll probably see that again in this video. The family Aguidae is right here on our phylogeny and is in about the middle of the tree. We'll start with the genus Anguis, also known as the slowworms. Slowworms inhabit essentially all of mainland Europe, the Isle of Britain, and several other Mediterranean islands. Other common names for these lizards include blindworms and the deaf adder. Found on the edges of woodlands and grasslands, they are also common in gardens, although they can be found anywhere where there's enough sun for them to warm up. They're not restricted to a specific habitat. They feed on invertebrates, and unlike most reptiles, slowworms are also known to hibernate during the winter from about October to March. Being burrowing lizards, they spend most of their time underground and are usually found underneath objects. For defense, slowworms are also able to shed their tails to distract from predators. Their tails grow back, although usually not the same size. Glass lizards in the genus Ophisaurus are found in North America and Asia, although some of the Asian species are sometimes the Asian species are put in a separate genus. The name glass lizards comes from the fact that, similar to slowworms, they can break off their tails for defense. Glass lizards inhabit grassland and open forest environments where they mainly hunt arthropods, although larger species may hunt larger prey. They lay eggs in clusters of 5 to 15, which are attended to by the female until they hatch. Interestingly, the oldest fossils of glass lizards are found in Europe, for which they are mostly absent today, aside from the far southeast, and they likely spread out from Europe into the more favorable climates of Asia and North America as the climate cooled in the latter half of the Cenozoic, which ended up wiping out the European populations. Sometimes when you're researching a topic, you come across a small aspect of it you haven't seen before and is surprising, and then suddenly becomes your favorite part of that topic, and you go down a rabbit hole. One such instance happened to me while researching this part of the video. Enter the Sheltopusik, the largest and my new favorite legless lizard, the only living member of its genus Pseudopus, closely related to the glass lizards mentioned previously. The Sheltopusik, also known as the Pal's glass lizard, European legless lizard, or Russian legless lizard, can be found in a broad range of habitats like forests, grassland, and even in environments created by humans like farms. They can be found in Eastern Europe, Central Asia, the Middle East, a broad range of habitats and regions from Croatia to Afghanistan. Sheltopusiks can grow to over 130 centimeters long, which is 4 feet, making it by far the largest legless lizard. Sheltopusiks hunt during the day and can be more commonly found above ground in wet weather, where they hunt for their favorite prey, snails and slugs, although they will also eat arthropods, eggs, and even birds and small mammals. Like glass snakes, they are able to lose their tail for defense. However, due to their size, they don't typically do this and we usually hiss and bite an adversary in defense instead. In terms of conservation, there is no data on the overall populations of this lizard, but they are locally abundant in most of their range, with only a few populations struggling with habitat loss. So they are classified as least concerned by the IUCN. Sheltopusiks have a fold of skin running down their sides, which you can see in the photo there, uh, that allows them to expand when taking deep breaths or swallowing large prey. All right, Amphisbaenians, also known as worm lizards, are probably one of the more well-known groups of limbless lizards, comprising around 200 species. Found in parts of South America, the Caribbean, North America, Africa, and the Middle East and Iberia. They live almost their entire lives underground, and because of this, relatively little is known about them, and they are seldom discussed. For example, when researching this topic, the April Fool's article from Scientific American about how they're somehow ancestors of mammals, which to be clear is not true, came up before the actual article on their biology did. Both of these are in the description if you're interested. All amphisbaenians are predatory. Most feed on invertebrates such as insects or worms, but larger species are known to feed on reptiles and rodents. They hunt in underground tunnels that they dig themselves with their shovel-like heads, although they are known to hunt on the surface. Um, some species are even known to tear chunks out of larger prey animals and then leave them to bleed out and die to finish them off later. Yeah, Amphisbaenians have many other adaptations for their underground lifestyle. As mentioned before, they have a shovel-shaped head to help them dig. They also have reduced eyesight and scales that form rings down their body, making them look segmented like an earthworm, hence the name worm lizards. Uh, this skin can also move independently of the rest of the body, allowing them to dig more effectively. There are 6 generally agreed upon families of Amphisbaenians, most of which only contain a few species, while Amphisbaenidae has well over 100 species assigned to it. Along with Amphisbaenidae found in Africa and South America, there are the Trilongidae found in Africa and the Middle East, and several other families found in Florida, the Caribbean, Mexico, and the Western Mediterranean, mostly around Spain and Morocco. Uh, Fossil Amphisbaenian, like lizards, date back to around the Cretaceous period, but the first true Amphisbaenians in the family Ruthenidae dates to the Paleocene of North America, just after the dinosaurs went extinct. And while there is some disagreement on the exact placement of the different family relationships to each other, it is generally agreed upon that this family is the first to branch off the evolutionary tree from the rest of the Amphisbaenians. And this family has an extensive fossil record with several species known from across North America. However, there's only one species that survives today, and that is in the Florida Panhandle, uh, commonly known as the Florida worm lizard, North American worm lizard, or thunderworm. It's a burrowing creature that feeds on invertebrates and usually stays underground, only surfacing when there's enough rain. The thunderworm's relatives being the first to branch off and branching off so early in the Cenozoic actually has some implications for the biogeography of Amphisbaenians. That when they made their way to other continents, such as South America and Africa, they had to cross the oceans. These small lizards that live underground, lacking limbs or even good eyesight, cross the ocean, likely through rafting. And this probably happened twice. Once to get from North America to South America, which weren't even connected at the time, and wants to get from South America to Africa. Okay, for the sake of time, I'm not going to cover every family of Amphisbaenians, but there is one other family I want to touch on, and then we'll move on to the next group of legless lizards. This being the family native to Mexico. Uh, they're unique for being the only group of Amphisbaenians that haven't lost all their limbs. Everyone meet the Mexican mole lizard, one of 3 species in its family native to Baja California. These are probably my favorite Amphisbaenians. Just look at those tiny arms. Their arms resemble that of moles, is where the name comes from, and they spend almost their entire lives underground, have incredibly poor eyesight. They are known to eat pretty much whatever they come across in their underground tunnels, mainly invertebrates like worms and termites, and they use their tiny arms to dig, similar to moles. All three members of the family have tiny arms. It's just the Mexican mole lizard is the most well known, which is why we're showing it here. The next group of legless lizards we're going to talk about are the snake lizards, or flap-footed lizards, endemic to Australia and New Guinea. Around 40 species of elongated snake-like lizards with no front limbs and hind limbs reduced to a single flap with no obvious toes, hence the name flat-footed lizards, which is certainly interesting evolutionarily speaking, considering that, as we just saw with the Amphisbaenians, most groups in this video will have lost their hind limbs before their front limbs, but these guys, it's the other way around. And here, once again, you can see on our phylogenetic tree of squamates, where at the top, the arrow is pointing to the geckos, the group these lizards belong to. Then next to it, you can see that that part of the tree zoomed in, where the family Pylonidae, which these lizards belong to, is clearly visible. It is odd for geckos, which is known for climbing on walls with their specialized finger pads, to lose their limbs entirely for a different lifestyle. Uh, but their isolation only being found in the continents of Australia and the neighboring islands of Papua New Guinea and the Bismarck Archipelago, which have been isolated from every other continent for millions of years, has also the evolution of many oddities that Australia is famous for, and that process of open niches being filled by animals that would not fill them in other continents likely has led to the evolution of these lizards out of geckos, other than another group of lizards that might be more predisposed to evolving this way with less specialized limbs. Snake lizards are usually solitary, terrestrial, burrowing arthropod hunters that inhabit a range of habitats, usually arid, in Australia and New Guinea. They are preyed upon by birds and snakes, as well as introduced predators such as cats and foxes. They move using lateral undulation, similar to how snakes move, and quite different from Amphisbaenians. Their eyes are well developed, even in burrowing forms. For reproduction, snake lizards lay eggs, usually two at a time, and some species are known to nest collectively. But one genus of snake lizards varies from this lifestyle, that being the genus Levias here, uh, which includes two species. The first pictured here is Burton snake lizard, found over most of mainland Australia. They differ from other snake lizards by being larger, and instead of feeding on arthropods, they feed on other lizards, including other snake lizards, swallowing them whole using their flexible skulls to immobilize the victims, much like a snake would. The other species in the genus is a Papuan snake lizard, very similar, except for the fact that it's the only snake lizard found outside of mainland Australia, inhabiting Papua New Guinea and the Bismarck Archipelago. This genus especially, but snake lizards as a whole, show very high convergence with snakes, even compared to other types of legless lizards. The next and perhaps strangest group of legless lizards is the genus Bachia, a clade of spectacle lizards in the family Gymorphidae. These lizards are native to northern South America and live underground or in leaf litter, hunting for soft-bodied insects. These lizards are known for having a lack of external ear openings and a unique type of eyelid. Back to the tree, the family that these lizards are in are shown here on the zoomed out graph, and the genus Bachia is shown on the zoomed in graph. Interestingly, they are closely related to Amphisbaenians, but their limblessness evolved independently due to both groups being more closely related to other lizards that have four legs than each other. But what makes this genus the most unique is how they lose their limbs. Most legless lizards and snakes are born without limbs, and the transitional state is being born with reduced limbs. While for many species in the genus Bachia, this is the case; they are born like that. But some species are born with hind limbs or forelimbs and lose them as they age, whether from an injury or through slow tissue erosion from their burrowing lifestyle, leaving many adults with knobs for limbs or even an odd number of limbs as one side of the creature's body could have limbs reduced more quickly than the other side. Many of the remaining groups of legless lizards are just a few species in a genus that independently evolved the limbless condition and a snake-like body plan, and several of these groups are in the skink family, one of the most diverse families of lizards containing 1,500 species. All right, back to our tree. Um, where are the skinks? The skinks are right here, all hundreds of species of them, right on this tiny little branch. The largest group of legless skinks is a subfamily known as lace skinks, which are endemic to parts of Africa. They live underground and are life-bearing. And other groups of limbless skinks include a genus known as limbless skinks, also unique to Africa, members of the genus Paracotis, which are endemic to Madagascar, the genus Skelotus, and several other species of skinks, but we don't have all day, and this video is about lizards as a whole, not just skinks, although apparently I could do an entire video made on the on independent groups of skinks that have lost their limbs and not just lizards. Our next group of legless lizards are the American legless lizards in the family Alenidae. This family contains just 6 species, is only found in California and the Baja California Peninsula. All are small burrowing lizards, less than 8 inches, 20 centimeters long, that live in sandy or loamy soil and feed on insects and insect larvae. Alenidae is in the superfamily Agamorpha, making them close relatives of monitor and alligator lizards, although their family itself is likely separated from other lizards by about 50 million years. These colorful lizards have many predators such as raptors, carnivorous mammals, anything that would eat a small lizard. So they rarely come to the surface and they only do it at night. Although their behavior is understudied, they seem to be solitary animals, tending to avoid one another. They give live birth of up to 4 young at the same time. Due to their restrictive range, only being found in California and the Baja Peninsula, many species have become endangered and been designated on California's species of special concern due to habitat loss caused by the growing development of that region. All right, and that's just about all the types of oh wait, there's more. Blind skinks are lizards, despite their name, are not actually closely related to skinks. Similar to many other groups we've looked at, these are burrowing lizards whose skulls fuse to help with digging and have lost their limbs. Although in blind skinks, the male still retains reduced hind limbs to help with mating. Like snakes, and unlike many other legless lizards that do not have external ears. Not only are these lizards not closely related to skinks, but they're not closely related to any other type of lizards or snakes, appearing sister to all other lizards in our phylogenetic study. Although in some studies they are placed within the geckos, and that group is sister to all other lizards. On the tree, you can see they're right there at the top. The family is generally split into 2 genuses, although this may not reflect actual relations. The first contains 1 species, the Mexican blind skink. This species is found in deserts and scrubland and dry woodland, where it feeds on insects and other arthropods, mainly anti-termites. While Dimebes, that's pronounced wrong, with roughly 23 species, is native to Southeast Asia and the Philippines, along with Malaysian archipelago, New Guinea, and unlike their Mexican relative, lizards in this genus are restricted to wet rainforest habitats, where they similarly feed on insects and arthropods. The final group of legless lizards that we will be covering in this video, because there are more, are grass lizards of southern and southeast Africa, which are different than the glass lizards of Asia and North America we've already covered. These include 5 species, which are closely related to spiny-tailed lizards and flat-tailed lizards. All members of their family are unique to eastern and southern Africa. These lizards still retain their limbs, although they are greatly reduced and no longer used for locomotion, which is why I'm including them in this video. They move much like a snake, and they have an elongated tail, which helps with this effort. They are restricted to grassland habitats, hence the name. These lizards mainly feed on insects, particularly grasshoppers. Grass lizards also give birth to live young, up to 17 at a time. And here is where they are on our family tree. All right, so if you recall at the beginning of this video, ages ago. We went through all of that to determine if we could find any commonalities between all the different types of legless lizards to find a reason for why they lost their legs and evolved that independently. And basically, all of these legless lizards, despite their varied ancestry, have very similar lifestyles of being burrowing carnivores of small animals, usually invertebrates. The only real exception to this being snakes. Uh, but one of the leading theories on snake evolution is that they evolved from small burrowing species very similar to the legless lizards of today, and then evolved into many different forms we see now. We can see a similar process happening with the snake lizards of Australia, where Burton snake lizard has evolved away from a burrowing lifestyle to a more active surface lifestyle, very similar to modern snakes. Adding to this, Sicilians, the other group of terrestrial limbless tetrapods, also has a burrowing lifestyle very similar to legless lizards. Many invertebrates, such as worms, also have this body plan for their burrowing lifestyles, so it appears that the reason lizards keep losing their legs is that a limbless body plan is very beneficial for a burrowing lifestyle. But that does bring up another question that if this body plan is the best for burrowing, why haven't mammals, which contain many different lineages of um, burrows, burrowing animals, adapted this body plan? Uh, the most likely explanation for that is that mammals are warm blooded, and the high surface area to volume ratio of a snake like body plan would not work well for that kind of metabolism, while a cold blooded animal, such as a snake, uh, would have a much less of a problem with that body type. And even with those limitations, some mustelids, such as weasels, have developed a long and thin body plan similar to that of snakes or legless lizards, although they have retained their limbs and do also live underground. So, in short, the reasons why lizards have independently evolved to lose their limbs more than half a dozen times is that their limbless body plan seems to be very beneficial for a burrowing lifestyle of small hunters, and their cold bloodedness means that do not have the drawbacks that a warm blooded animal would have for that very body plan, which I just find so fascinating. And people around me are tired of me talking about it, so I put it on YouTube.